Hey friends, this is Mrs. Walton subbing in for Mrs. Goulandry. As Mrs. Goulandry is away on maternity leave, what I've decided to do is make some videos to help you guys understand Algebra 1. I am just down in room 212. Some of you guys might have had me last year, but if not, feel free to say hi. And we are going to be exploring Unit 4 together. So here's what we've got. Unit 4, we have systems of linear equations and inequalities. And when I see systems, well, we already know what linear equations are. We've known how to write them, graph them, work with them all from last chapter. And a system is simply a way to say, hey, instead of one linear equation, what if we have two things that we are analyzing? What if we have three? Let's go crazy. What if we have four? So we're going to be talking about relationships between more than just one thing. We are going to be looking at multiple relationships and how those fit together. And the first thing that we are going to look at that kind of fits together is supply and demand. Companies from McDonald's to Walmart rely on hourly workers to prepare food, work as cashiers, so on and so forth. So imagine a business is opening in a new city and is hiring. The following table shows how many people would want to work at 3 different hourly wages and how many the company would want to hire. So we've got 2 different things going on here. First off, let's talk about the different wages. $3 an hour. There's probably not going to be a lot of people that want to work for $3 an hour. That is just not sustainable. So in this case, at $3 an hour, only 72 people want to work there. Let's bump that up, $5 an hour. Well, $5 an hour, 120 people want to work. More people are willing to work. $12 an hour, even higher. That is at 288. And sure enough, as your wage increases, the number of people who would want to work there is probably going to go up. I love my teaching job, but if McDonald's all of a sudden were to decide to pay $50 an hour or $100 an hour, well, call me SpongeBob. I'm going to go start flipping some patties. So as that wage is going up, so is the number of people who are going to want to work there. Now, let's say that McDonald's was hiring and they were paying $50 an hour. Well, it is not in the company's best interest to pay a ton of workers $50 an hour. So let's look here. If they're only paying $3 an hour, well, they're willing to hire 256 people. If they're willing to pay $5 an hour, well, they can't hire as many people because they are paying more. $12 an hour, that is all the way down at 184. And let's say that it is $100 an hour. And that could be maybe all the way down at 1. Mrs. Walton, SpongeBob SquarePants, that's us. All right, so we've got 2 different relationships here. First off, the wage. How is supply affected by that wage? More and more people want to go and apply for that job. Demand, well, the company's not going to be able to hire that many people. So here's what I would like for you guys to do. Let's go ahead and look at the next page. And we have our supply, how many people would want to work there. And we have our demand, how many people are they willing to hire. And just as we predicted, this is going up, this one is going down. Now, what I would like for you guys to do, and Mr. Parsons is going to pause this video here in a moment, but what I would like for you guys to do is try to write a linear equation through these points and write a linear equation through these points as well. Now, for some of you guys who have enjoyed your 3-day weekend, let's real quick remember how to do that. You guys know how to do this. If I have 2 points, I can write a line in between those. First thing that you need is you need your slope from here to here. I went up 1, 2, and over 1, 2, 3, 4, 5, 6. Up 2 over 6. Y equals up 2 over 6. If you wanted to, you could go ahead and simplify that to 1 over 3, but I'm going to go ahead and leave that. Now, you do need to locate, hey, we went up 2 over 6. Well, we got to determine what point it goes through. We could choose this point. This we went right 1, up 3, so we would have x minus 1 plus 3. Sure enough, we just wrote a line that goes through those 2 points. Now, if you would have chosen the other one, fret not, it would work out as well. Our slope, I'll go ahead and simplify it for this one, 1 over 3. And if I were to have chosen this point, this right 7 up 5, well, x minus 7 plus 5, voila, there you go. Both of those lines going through those 2 points. All right, so Mr. Parsons is going to go ahead and pause the video. What I would like for you guys to do is go ahead and write an equation for our supply and one for our demand. And go. Let's see how you guys did. All right, so here were my equations. First off, for our supply, what I've got going on here is this equation right here. We have y equals 24, x minus 3 plus 72. For every additional dollar, what I got for my slope was for every additional dollar, 24 new people are going to want to go and apply for that job. So that is our beautiful equation. Now for our demands. For every dollar that we increase our wage, the company can hire 8 less people. So that's going to go down. That's why from $3 to $5, that went down by 16 people. All right, so we have a few questions to answer here. So here is what we have. In the United States, the federal minimum wage is $7.25 per hour. This is the lowest amount that an employer can legally pay its workers each hour. If the company only pays minimum wage, can it hire as many workers as it wants? First question we want to figure out is what happens if they only pay $7.25? Next one, what is the lowest wage at which the restaurant will be able to attract as many employees as it wants? So what is that break even? What is the perfect wage where those two things meet? And finally, what would occur if the minimum wage was $15 an hour? There is a big push now to get the new minimum wage to $15 an hour. So what I would like for you guys to do is go ahead, take a few moments, and I want you to talk about these 3 questions. First off, $7.25. What's happening at $7.25 an hour? Next one, what's our perfect break-even point? And then finally, what is going to happen at $15 an hour? So Mr. Parsons, go ahead and pause the video. Your students are going to talk about those 3 questions. And go. All right, first question, how do you analyze what is going on at $7.25 an hour? This is our minimum wage for the federal level. So $7.25 an hour, let's see what's going on here. First off, $7.25 an hour will bring in 174 applicants, 174 people who would want that job. However, the company would want to hire 222 people at $7.25 an hour. So unfortunately for this company, $7.25 is not going to bring in as many workers as it would like. However, our perfect break-even point is right here. $8.75 an hour is going to be the perfect meeting point. 210 people would apply for it, and 210 people would be the amount that the company would want to hire. So 210 is the perfect amount. And one way that you could have figured this out, well, let's go back to those 2 equations. If you solved, well, hey, -8, x minus 3 plus, what was that? 256. 256 equals 24 times x minus 3 plus 72. If you solve that equation, you could have gotten that x value. You could have gotten $8.75. That would be the perfect wage for that. You could have done this graphically as well, but if you're kind of like me with a straight line challenge, it might be a little hard to see that perfect intersection on this graph. But $8.75 is the perfect amount. Now the last number that we wanted to discuss was $15 an hour. What happens if we were to raise this up to $15 an hour? Well, let's look here. 15 an hour. Oh, go back. All right, 15 an hour. Here's what is going to happen at 15 an hour. Well, at 15 an hour, there are 360 people that would want to apply for that job, but the company only would want to hire 160. So in this one, if the minimum wage was $15 an hour, that company could be very, very selective. They're going to have tons of applicants, and in fact, they're going to end up turning away 200 people from what they need versus what is going in. So if that minimum wage was 15 an hour, they're going to get a lot of applicants. And just for funsies, let's say that they were to raise this all the way up, like I said, to 50 an hour. Just for fun. Let's see how many people would apply. If you have a wage of 50 an hour, 1,200 applicants. And this would actually end up being negative 120. This would mean that the company is probably going to end up losing money if it pays its workers 50 an hour. We could have guessed that. But that is what we have going on there. So there's the few situations that we looked at. We looked at minimum wage. We looked at that break-even point. And finally, we looked at that 15 an hour. So this is essentially what we are going to be looking at this unit. We are going to be talking about systems of equations. We're going to start off by graphing. And then we're going to figure out that maybe graphing isn't the best model. And then we're going to go towards some actual analytic methods, solving algebraically. So here's what you guys are going to do for practice. We have a fun Desmos activity, so you guys will need to grab some Chromebooks. And what I would like for you guys to do is go to here. We have student.desmos.com, and your class code is D5UX2K. Hope you guys have a wonderful day. Have fun with this activity. You're going to see some turtles racing, and I hope you guys have a wonderful day. Thanks.